Hi friends, it's obvious that if we want to work with digital communication, yes, definitely the continuous time domain has to be converted into discrete time domain, and for this we go for sampling. Now the issue is when to sample. So sampling is a process of pinpointing a particular instant and measuring the value at that instant and noting down. So the question is where that instant can be. So it can be anywhere, but it has got some requirements. It has to meet some requirements. So let's first assume that our samples for this input, which is a continuous domain system, is taken at these points only on the peaks. So this curve is not known to us. After sampling, what we get is one sample here, one sample here, one sample here, and one sample here. So we get these four samples, and if we look at these samples, it appears that the input is constant, it is not varying. So we may assume that the input in continuous domain may be looking like this. Yes, definitely it is an error. So we can't work this way. Then can we change our working? So we take one sample here, then one sample here, then one sample here. If we do that, then what are we getting is this. So we get a sample here, then we get a sample here, then we get a sample here. So looking at this, it looks like this. Yes, it is moving up and down. So there shows some oscillatory behavior. So sometime it is positive, sometime it is negative. Again, it is going positive. So we may expect the next thing may go negative and so on. So in that case, we try to approximate the input like this. So what are we trying to do is for these points, we are trying to find a curve that fits the most accurately. Okay, the next option would be to work with these samples. So what we get with that is one here, 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 and so on. Yeah, it looks oscillatory, of course. And then if you want to go for a linear what do you say, fitting, then it can be this. If you want a best curve fitting, then what you get is this. And this is what looks similar to our input. So what it says is, if you want to get almost best fit with a curve, then we should have minimum 2 samples in one cycle of the input. That means if the input has got a period of t, then the instance where the sampling is done has to be less than t by 2. So the sampling time should be less than t by 2, or if f is the maximum frequency we are working with, then we should have at least 2 samples in each cycle. That means our sampling frequency must be at least 2 times the frequency of the signal. So that's what our sampling theorem says. So if what are we doing here is, we are taking one sample in one period. So that is talking about, this is fs equal to f, and we get this problem. In this case, the samples are not taken even one sample in one cycle. So more than one cycle is required for one sample. So that means the sampling rate is less than the actual frequency. In that case, what you see is you get a confusion that your signal has got a lower frequency compared to the actual frequency. So this is what we may approximate by mistake. And if it is 2 times in a cycle, if we do it 2 times in a cycle, then we get this. And if you want a better results, so definitely we would recommend you to get more samples in a cycle. The more samples you have, the better approximation we get for a this one I am not drawing to the scale, just to make sure what we are trying to understand is, the more samples you have in one cycle, the better approximation you can have for that particular signal. So these are the samples, and that is trying to get us the actual continuous signal. So with less number of samples, the approximated continuous signal is totally absurd, may not have any information about actual signal. If it is less than that, even it gets worse. If it is twice the frequency, then we get a little insight of our signal. But if it is very much more than the signal, that is in one cycle you have large number of samples, then definitely this curve is a better approximation for the actual signal which we have found from these samples. So that's the sampling theorem. It says that the sampling frequency has to be very much bigger than the frequency used. So that's sampling theorem. Thank you.